Hello, everyone. I'm Wentong Shu from Beihang University. It's a great honor to give the presentation here. Today, I will introduce our paper, Can I Get There? Negotiated User-to-User Teleportations in Social VR. The growing adoption of social virtual reality platforms underscores the importance of safeguarding personal VR space to maintain user privacy and security. As a prevalent instantaneous locomotion method in VR, teleportation facilitates users' engagement, but can also invade personal VR space, thereby raising privacy and concerns. Teleportation may create inappropriate formation within personal space, negatively affect users' collaboration. Malicious individuals could invade users' privacy without permission and use frightening avatars to cause discomfort and fear. Our related work is about personal space and teleportation. In social VR, personal space depicts the area surrounding an individual, with its dimensions and form influenced by various factors. The top left studied the impact of virtual avatars' emotions on personal space. The bottom left proposed a multi-level specification of personal space from different entities. The right investigate group teleportation and collaboration in social virtual reality. However, research on user-to-user teleportation with personal space protection is adequate. This raises the question: how to teleport to someone without invading personal space? To address these risks, we proposed negotiated user-to-user teleportations. In this paper, we have introduced and evaluated three innovative negotiated teleportation techniques, which are designed to secure user-to-user teleportation and protect personal space privacy. We also developed a unified framework for negotiated user-to-user teleportation, which streamlines the interaction between the host and the guest users in a social VR environment. In our study, the personal space of the host user in social VR is conceptualized as a circular area. Drawing from established dimension of personal space, we have delineated it for teleportation into four distinct zones. The public zone allows guest users to teleport without any limitations. Upon the guest user's teleportation attempt, the notified zone triggers a notification to the host user. The negotiable zone, which lies within the 45 to 200 centimeters range, bridges the transition from the social to personal. We proposed three innovative negotiated user-to-user teleportation techniques within virtual environments: sector technique for directional control, distance technique for minimum social distance control, and area technique for defining circular permissible teleportation areas. This is the workflow for our techniques. Within the negotiable yellow zone, the host user can choose a teleportation permitted green area for the guest's teleportation. The first two techniques employ DOF separation to distribute the spatial dimensions of personal space, while the third technique employs an averaging approach. In sector technique, the host user can choose one of the 8 sectors as the guest user's teleportation area. Then, the guest user can select any location within the designated sector for a single teleportation. In distance technique, the host user can adjust the radius to determine an arc-shaped zone for teleportation. The guest user is granted the freedom to teleport within the personal space outside of this radius. In area technique, the host user can define the position and radius of a circular area as the teleportation zone. After the host selection, the guest user can teleport to that circular area. In order to prove that traditional teleportation could cause significant anxiety to users due to the invasion of personal space, we conducted a preliminary experiment measuring the personal space invasion anxiety level using the teleport without negotiation. Each pair of participants was involved in a 20-minute teleportation experience within a campus VR environment, which included various social user-to-user activities using traditional teleportation, such as communication, collaboration, and handshake. Following the experiment, participants were tasked with completing a PSIAL questionnaire. The results indicated that traditional teleportation could invade personal space and cause significant anxiety for users. To evaluate the three negotiate teleportation techniques, we conducted a multi-user VR experiment within a virtual campus environment. We maintained the same number of participants as in the preliminary experiment and recruited additional people. Pairs of participants were tasked with evaluating each technique across three tasks: communication, collaboration, and handshake. Drawing from prior research, we employed key metrics to evaluate the performance of the proposed techniques: efficiency, effectiveness, preference, embodiment, usability, and PSIL. In our user study, users were asked to complete three social tasks. We used the red robot avatar to represent the host user, and the blue for the guest. This is the box plot results of effectiveness, preference, embodiment, and usability scores. The results show that all three techniques significantly enhance personal space protection and have equal abilities in mitigating external stimuli impacts. In addition, area performs best in terms of effectiveness, preference, and usability. However, in the usability questionnaire, specifically for questions pre-training to the difficulty of technical learning, the area method received lower scores. The experiment also measured the negotiation time and PSAL score for three techniques. Area has the shortest average time and the highest efficiency in fulfilling intentions. Most importantly, the results of the PSIAL score show that our techniques significantly reduce anxiety during teleportation events. Our work also have limitations. First, our representation of personal space is relatively simplified. More personal space attributes also deserve to be considered. In addition, our techniques were designed from the perspective of the host user, with less emphasis on the experience and needs of the guest user. Our future work will analyze user strategies for managing multiple and group teleportation. Furthermore, future work should explore the use of more neutral avatars and how different types of avatars affect personal space teleportation. Thanks for watching.